All right, this is Algebra 1, Lesson 5.5, Function Rules. So Algebra 1, make sure you're at the right lesson. 5.5, we're going to take a look at function rules today. All right, so let me get my shade up here and we'll get rolling. Okay, number 1, the rule, and that's what we're talking about right here, function rules. The rule of a function allows for the pairing of each abscissa with its ordinate. Remember, your abscissas are the x values and the ordinates are the y values. So what does the rule allow you to do? It allows you to pair everything up. The pairing of the x with the y, right? Pairing of the abscissa, the x's, with the ordinates, the y's. That's what we're talking about, and that's what's going on. All right, so let me reveal a little bit here and take a look at this function right here. F of x equals 3x plus 1. F of x equals 3x plus 1. Again, just a reminder, f of x is short for a function of x, but generally in speaking, we just say f of x, and that's this part right here, right? F of x. Okay, so we've got f of x equals 3x plus 1. The x is the independent variable. The x is the independent variable, right? But here's the key, and it's the only reason I brought that up, is the f of x is the dependent variable. The f of x is the dependent variable. So then that brings us to an important aspect right here, and I'm going to put an asterisk here at little b. F of x and y are interchangeable. F of x and y are interchangeable. So then y equals 3x plus 1. So look at these two. You got functional notation here, and you just have equation form here. Those are exactly the same. The f of x and y are interchangeable. F of x and y are interchangeable. Remember, f of x is the value of the dependent variable. Okay? All right, we'll use that a lot. C, given the function rule and the domain. Remember, the domain are all the x values, right? Giving the function rule and the domain, the entire function is defined and can be, and we can do now 4 different things with this. Okay, we've got 4 different possibilities. Can be written as a table. All right, I'll show you that in a minute. Can be listed as a set. We've done that before. Number 3 can be graphed. We've done that already. And 4 can be illustrated with a mapping diagram. And we've done that already. But that's just the reality. There are 4 different ways we can represent a function and its rule given a set domain. Okay? All right, so let's take a look at the next aspect here. All right, so we've got this example. So I've got the same function here, right? F of x equals 3x plus 1. But notice we were given the domain. So given the domain, and it tells us -2, 0, 1, 2. All right, first thing we're going to do is the table. First thing we're going to do is the table. And by the way, you got a little graphic here out of the Bob Jones University Press materials, right? Domain is the independent variable. You put the value of the domain into the function, and what do you get out? The value of the range, right? The value of the y. So you put in the x, you get the value of the y. All right, so our first domain is -2. And what we want to do is, within the rule, right? We're using this rule right here, and we're just substituting. Let me use my color here. Remember, I always put a parentheses in for where the variable is. If you'll do that, you'll be safe from negatives. That's usually what gets you. Well, this is a -2. And so now we can do that in our head, -6, and 1 is a -5, and I'm going to write that in green, right? F of x is -5. Now remember, don't forget, f of x is the same as y. Same thing. F of x and y are the same thing. Okay, and we'll just go through and repeat this process. So I'm going to do it a little bit more quickly. I'm going to do 0, 1, and 2. And in each spot of the table, I'm going to prepare it first with my blue. 3 parentheses plus 1, 3 parentheses plus 1, 3 parentheses plus 1. And again, we're just going to fill in with the independent variable, the value of the domain. The abscissa on the second one is 0. The abscissa on the third one is 1. The abscissa on the fourth one is 2. And we'll just solve each equation. The rule is going to give us the value of the dependent variable. Okay, the second one is 1. So abscissa 0 is paired with ordinate 1. Right? And then the third one is 4. So abscissa 1 is paired with ordinate 4. And the fourth one is what, 7? So abscissa 2 is paired with ordinate or image 7, right? Or you can think of it this way, input 2, what do you output? 7, right? Input 2, what do you output? 7. Look at the graphic over here on the right. So we're going to input 2. It's going to go through the function machine, and what do we end up with? We output a 7, right? Input 2 and output a 7. All right, so that's the table. Let's go on to the other possibilities, right? So we got a table, and I need to be higher, so let me get rid of my shade so I can do that. Okay, get my shade back here. All right, second situation. Second situation is just to list it as a set. All right, I still need to see the original function. So because I already have a table, I'm going to use the table to list it as a set. All right, so I learned from the table that guy -2 is with girl -5. So parentheses, -2, comma, -5, parentheses, right? And now we're just going to go through and list all the XY pairs. Second one, 0 is with 1, 1 is with 4, and 2 is with 7, right? Don't forget your braces. Coordinate sets of coordinates in ordered pair always goes in parentheses, comma, between the x and the y value, right? And there we have it in set form. All right. The third possibility is graphed form. Okay, so here's what I'm going to do. I'm going to look. I could either look at my set form or my table form to know where to graph the points. I'm just going to look at set form. So I know I have the point -2, 5. So I say to myself, go left 2 and down 5. And there's that first point, right? Second point, 0, 1. Don't go left or right, but go up 1. All right, we're right there. Third point, 1, 4. 1 to the right, 4 up. And we are there. And our last point, 2, 7. 2 to the right, 4, 5, 6, 7. 7 up. By the way, if you ever run out of space on the graph, just keep going if you need a point a little bit higher or a little bit lower. Okay, so there is our function graphed. It's a set of 4 points. And that leaves us then with the last thing, and that's a mapping diagram. Now, one thing I always want my students to do is list the domain, and then also what would you put over here. So the first oval is the domain, the second is the range, right? And again, remember, you don't need to write this, but the domain is the input and the range is the output, right? Okay, so we're just going to go through and list the members of the domain. Remember, nothing gets listed twice if there are any things that get listed twice. So -2, 0, 1, 2. And we got negative 5, 1, 4, 7. And don't forget, you must map them. Mapping them says show the connection. And so 2 is mapped to negative 5, 0 is mapped to 1, 1 is mapped to 4, and 2 is mapped to 7. Okay? Is this a function or just a relation? Everything's paired, so it's a relation. But is it also a function? And you should say, yes, it is a function because any abscissa has only one ordinate. Or as I like to say, any guy is dating only one girl. All right? If that is the case, we have a function and we are good to go. Okay. Go to the back of your notes there. I'll get my shade up. Okay, so now we gotta do something about the rule. Now we want to find the rule. So number 2, to find the rule, use the template, and it's right here. You got to know that. You got to know that. So, asterisk that. I put it in a nice blue box for you. But you got to know y equals mx. All right. So all we need is this. We need to find the value of m. That's all you need to know. If you know the value of m, then you can find the function rule. That's it. All you need to know is the value of m. And m represents the slope. We are going to talk about slope in detail down the road. So I'm not going to go into it now. We will talk about slope in a lot of detail down the road. But suffice it to say, it's basically this. The slope is the vertical change. The vertical change. So what's the top of the slope? The vertical change. Which one's the vertical, the x or the y? And hopefully you're thinking the y. So this is the change in y, the vertical change. In math talk, that would be a triangle y. And the triangle is delta, or change in. Delta y means change in y. So vertical change. The bottom is the horizontal change. And so that would be delta x, right? Because x is the horizontal ones. So you get the vertical change, right? Talking up, down, right? That's the top. And on the bottom, what have you got? You've got the horizontal change, right? The left, right. Okay. So for us, we got to figure out the value of m. If we can find it, we can write the rule. We can write the function. Okay, so how do you do this? You have to analyze the gaps of the range. That will get you the vertical change, because isn't the range the y values? And on the bottom, you have to analyze the gaps of the domain, because the domain is, of course, the x values. If we can do that, we're going to be able to write the rule. Okay. So let's take a look at the first example here. All right, so the instructions say find the rule for this set: 1, 4, 2, 8, 3, 12. All right, first thing you want to do, put it into an XY chart. XY chart. All right, that's chart, of course. But if you're from Jersey, it's chart. All right, put it into an XY chart and analyze the gaps. Put it into an XY chart and analyze the gaps. A little bit better there. Okay. So if you look here to the right, I've already got it in an XY chart, right? Right up here, top right of the screen. Okay, so we're ready to roll here. We're already in an XY chart, and we're going to analyze the gaps. Now, what's the top? The gaps of the range, or I'm sorry, the gaps of the domain or the gaps of the range? And it's the gaps of the range, right? Top is the vertical change, the gaps of the range. So I want to do that first. Let me keep this to there. So that's what I want to do first. So I'm going to look at the gaps. Okay, I'm looking at the first two numbers. I go from a 4 to an 8. Okay, that's a gap of 4. Now I go from an 8 to a 12. That's also a gap of 4. The ones we're doing, the gap is going to stay consistent. And it does. We have a 4 gap. So I'm going to come down here and say a gap of 4. What do I do with that 4? That's the vertical change. It goes in the top for my slope. So I know M is a 4 on the top. Now let's analyze the gaps of the domain. Between a 1 and a 2, there's 1. Between a 2 and a 3, there's a 1. Again, we're going to have a consistent gap in the ones we're doing. Got a gap of 1. That goes in for the horizontal change. That's it. All right, so remember, look at the top right of your screen. Here's the key, right? And so here it is. All we've got to do is take y equals mx and sub in the value for m. That's all we need. We just found m. What is the value of m? The value of m, 4 divided by 1 is 4, and that's it, y equals 4x. That's it. We found the rule. And look, now that we know the rule, if the domain is all the real numbers, we can find any value we want by substituting it in. Boy, I wonder who Guy 100 is dating. Well, let's find out. Guy 100, all right, put in 100 for the x value and figure out that he is dating girl 400, right? We just found the pair. Oops, let me get my red there. We just found the pair 100, 400, right? And we can do this for, now we can find the pair for anything. Guy 1/2. What's 4 times a half? 2 is dating girl 2, right? Abscissa 1/2 is with ordinate 2, etc., on and on you go. It's infinite amount of possibilities there because the domain is all the real numbers. But we can do that now because we know the rule. Okay, last one. Oh, 2 more. Sorry about that. Let's get that shade back up there. All right, come on, shade. Okay, so here we have now just same situation, find the function rule. So remember, what's the first thing you're going to do? XY chart. All right. -3, -3. 0, -2. 3, -1. 6, 0. All right. We're going to list the abscissas and ordinates in an XY chart. What do you do next? Analyze the gaps. What gap are you going to analyze first? The domain or the range? All right. And hopefully you are going to do the range. So let's take a look at the gap. I go from a -3 to a -2. Okay, that's 1. Notice here, 1. Notice here, 1. So let's go to the left here and set up our m. So remember our m equals, and so what goes in the top? Our vertical change, 1. Let's analyze the gaps of our domain. Okay, that's a 3. 3, 3. Again, we're doing consistent gaps. So what's the change in the horizontal every time? It's a 3. How do we finish? Remember, y equals mx. All we've got to do is stick the value of m into the template, and we get y equals 1/3 x. And once again, we can now find every other xy pair. All of them, now that we have the rule. Now that we've got the rule, we know every other xy pair. A lot of value there. All right, last example. If you'd like to do it yourself, I would pause the video, go ahead and work through it, and then turn the video back on and see if you got it correct, and that's what I would advise you do. Go ahead and do this one yourself. and then unpause the video and see if you got it right. All right, let's list out. We got 1, 8. We've got 3, 5. We've got 5, 2. All right, I'm going to set it up already. I know M is going to equal vertical over horizontal. Analyze my gaps. Uh-oh, wait, from an 8 to a 5, that's a -3. Uh-oh, from a 5 to a 2, that's a -3. You said, I didn't know they could be negative. Why not? Sure, absolutely. You can have positive slope and negative slope. Okay, let's analyze. All right, let's stick our vertical change in there. Let's analyze the gaps of our horizontal change. All right, that's a 2, and that's a 2. We got a 2 on the bottom. Template, y equals mx. Therefore, y equals, what's our m? -3/2 x. Again, once we have the function rule, we can now solve for any pair, no matter what. All right, that's the lesson. These are foundational lessons. We're going on to graphing lines and lots of things involving graphing. So try to work hard at understanding and ask questions tomorrow in class, and let's get solid on these concepts. All right, have a let me just do one quick review with you. All right, so what did we talk about here? All right, remember the rule. What is the rule? It's what the function equals. You've got f of x is the dependent variable, and the thing I have to stress is this. Don't forget, f of x and y are interchangeable. That is so, so important. F of x and y are interchangeable. If you can remember that, you're in great shape. And what does the rule allow us to do? Did you see that now? Didn't the rule allow us to pair abscissas with ordinates? And once we know the rule, we can pair any abscissa with any ordinate. Okay? All right. Have a great night.